The sixth lesson in chapter 8 is the sine and cosine lesson, where we build on the tangent ratio and apply the sine and cosine ratios, which are as follows. The sine of an angle is equal to the ratio of the opposite to the hypotenuse, and the cosine of the angle is equal to the ratio of the adjacent leg to the hypotenuse. Taking a look at the three drawings, now we have sine, cosine, and tangent, all with their respective ratios. One of the acronyms that people use to remember what the ratios are is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Some old horse caught another horse, taking oats away is another way you can remember that. I just remember the ratios. Find the values of x and y to the nearest integer. The sine of 67 degrees and the cosine of 67 degrees looks as follows. Using the ratios and the sine and cosine functions, you have the table on page 311 in your textbook to find the sine of 67 degrees, which is 0.920, and the cosine of 67 degrees, which is 0.3907. In that case, you take those two ratios, multiply them by 120, and you have x equals 110 and y equals 47. Take a second and answer questions 1 through 10 on your worksheet using the cosine and sine functions, as well as the inverse cosine and sine functions on your calculator. You can also look at the chart on page 311 in your textbook. On numbers 11 through 14 on your worksheet, you have finding the values of x and y given the angle of one of the angles of the right triangle. Obviously, the other angle can be complementary to that. You can use either sine, cosine, or tangent, depending on which you prefer. But remember, you're finding the side length with the inverse of the sine, cosine, or tangent function because the angle is given to you. Take a look at the problem here. An isosceles triangle has sides 8, 8, and 6. Find the lengths of the three altitudes. First hint that I'll give you, and then I'll let you solve from there. There's your drawing with the information given. From there, we have to find one of the angles. In this case, it would be x or a, and therefore we could find the cosine of angle B is equal to the adjacent over the hypotenuse, 3 over 8. Therefore, the angle related to the ratio of 3/8 is 68 degrees. Therefore, angle B as well as angle A is 68 degrees. We then have to find the other altitudes. So there is an altitude drawn from angle A and from angle B, and those angles would both be the same because obviously it's an isosceles triangle. So, given that information, the hint for that, we know that angles A and B are the same, and when we draw an auxiliary line from A to CB, we can use the ratio of opposite to a hypotenuse, and that's the sine ratio. So we use the sine of 68 degrees equals y, which would be the altitude, and 6 is the hypotenuse of the right triangle. Therefore, the sine of 68 degrees is 0.9271, and we multiply that times 6, and you get 5.631. So to the nearest integer, we're looking at about 6 units. Take a second and finish the rest of your worksheet. Bring it in for questions on Monday, April 21st. Enjoy your spring break.